In our last video, we discussed the ninth property of square numbers. And if you haven't watched the video, you can find the video link in the description box below. Please watch it because now in this video tutorial, we are going to solve some problems based on that property. But let me quickly recall it. You have two consecutive square numbers, n and n plus 1. You would find their square numbers, that is n squared and n plus 1 squared. So these two are now two consecutive squared numbers. And if it is asked to you that how many numbers will come between these two consecutive square numbers, how many numbers, and those numbers will be what? Are non-square numbers. So those numbers, the count of those numbers is given by this 2n. What is this n? This n is this one. Now let's quickly solve some problems based on this. And that's why I have said that you should watch that tutorial first. And if you have watched that, then this tutorial is, solving the problem is very easy for you. It's a piece of cake for you. Now, how many natural numbers lie between 100 squared and 101 squared? So this is 100, this is 101, this is squared and this is squared. It means what? If I take this first one, it means that here n is what? N is 100. And what's n plus 1? N plus 1 is 101 here, right? N plus 1 is 101. Now if you take the square of this one, this becomes what? 100 squared. If I take square of this one, this becomes 101 squared. That's what we have here. Okay, it means that these two are consecutive square numbers. These two are consecutive square numbers. And what's asked to you? What is the question? How many natural numbers? So if we find out, the number of square numbers that come between 100 squared and 101 squared by the formula 2n, where n is what? 100. N is what? 100. So this is 2 times 100. And this gives us 200. This 200 tells us that there are 200 non-square numbers, 200 non-square numbers that come between these two consecutive square numbers, that is 100 and 100 squared and 101 squared, right? These two are two consecutive squared numbers, and there are 200 non-square numbers that come between these two squared numbers. So what are non-square numbers actually? They are natural numbers only, right? They are natural numbers only. So if I find out non-square numbers, it means that I have found out all the natural numbers that come between these two consecutive square numbers, right? Same thing here. This is 999 squared and 1000 squared. This is 999, that is, this is n, this is 1000. It means that this is n plus 1. So what's the value of n? N is 999. Now if we take the square of it, that is, if we find out the square number of n, that is 999 squared. If we try to find out the square number of n plus 1, that is 1000 squared. So now we have two consecutive square numbers. We have two consecutive square numbers. And we have to tell natural numbers that lie between these two numbers. Now all those numbers that come between these two consecutive square numbers are actually what? Are actually non-square numbers. And to find out that count is 2 times n, the formula. So 2 times n means what? You have to do this one, right? So if you find out this one, this is 2 times 9 is 18. 1 carry over, 2 times 9 is 18 and 190. You have 1998 non-square numbers that come between 999 squared and 1000 squared, and these are actually what? Natural numbers only. Non-square numbers are natural numbers only. Now let's quickly move to the next problem, and it is how many non-square numbers lie between the following pairs of square numbers. The first pair is what? 503 squared and 504 squared. Now obviously these two are consecutive square numbers, 503 and 504. It's just similar to what we have done here. They have just changed the words. Here you have, they asked natural numbers, but here they are asking non-square numbers. It's same. The formula is 2 times n only, because even in this case 5, if here n is 503, n is 503 and n plus 1 is 504, right? So if we find out the square of this one, that is the square number of n, so this is 503 squared. Square number of n plus 1, this is 504 squared, right? Now you have two consecutive square numbers, and you have to tell now all the non-square numbers that come between these two consecutive square numbers, and the formula is 2 times n. N is what? 503, so times 2. If you do this, you get 2 times 3 is 6, 0 and 1006. This is the count of all the non-square numbers that come between these two pair of consecutive square numbers. Let's solve this one. This is 1098 squared and 1099 squared. Again, n in this case is 1098 and n plus 1 is 1099, right? If you find out the square number of this one, this is 1098 squared. Square number of this one, you get squared. You have now two consecutive square numbers. And now you have to tell the count of non-square numbers that come between these two consecutive square numbers. Formula is 2 times n. It means 2 times n is what? 1098. This is 2 times 8 is 16, carry over 1, 2, 9, 18 and 19, 1 and 2. So the number of non-square numbers that come between these two consecutive square numbers is 2196. Remember, this formula is valid only when you are taking two consecutive square numbers. It's not true for two non-consecutive square numbers, right? So if you haven't watched that video where we have discussed this theoretical portion of this property, then this will be tough for you. But if you have watched, it's really a piece of cake for you.